Good day mga kamatiks! Kumusta kayo dyan? Dito naman ako, si Sir Navero. Welcome sa ating panibagong tutorial video. The content of our video today is all about radicals. Radicals, the definition of radicals, and transforming rational exponents to radicals and vice versa. First, let's define radicals. So, ano nga ba ang mga radicals? Okay, radicals, these are expressions containing radical sign. Obviously, what is the radicand? The radicand is yung expression sa loob ng radical sign. Alright? Then the index. Okay, it tells you how many of a kind you need to put together to be able to move the number or variable from inside the radical to the outside of the radical. So this definition will be given highlight in the next following video. But for now, there will be no example that you need to take out the how many of a kind of a certain variable of a number or a number. Alright? So in radicals, you have to take note of some few things. Okay, so note that if the radicand of a square root is a negative number, the radical is a real number. Okay, so it's just a particular reminders for this discussion. But since we're not going to simplify yet, so this will be highlighted in the next following videos. Okay, so let's have a thorough visualization of what a radical is. So, first is we need to define where did radicals come from. So rational exponents, for example, a to the power of 1 over n are commonly known as radicals, no? In which the n value represents the root of the index of the radical. So yung n natin dyan, it could be any number, right? So it's just a general form, right? So from rational exponents, we can write these expressions, the rational exponents, to radical, okay, to radicals, in which here is an example: a to the power of 1 over n, which is equal to nth root of a. So again, you read it as nth root, right? So this thing here, okay, so this is nth root of a, right? So which one here is the radical? So this whole thing is a radical. Which are the parts? Okay, so this one here is the radical symbol, okay, and then this one, the inside, the definition earlier, inside is the radicand, and then the n is what we call the index. Okay, so note that the square root or 1/2 exponent is the common radical and does not need to have the index written. So what does it mean? So if a particular example, a to the power 1/2, when you write that into radical form, you don't need to write anymore the index, which is the denominator here. So if you notice, there's no number written here anymore. So this is what it means: the square root or 1/2 exponent does not need to have the index written in the radical form, right? So let's have the property that is commonly used in transforming and simplifying radicals, right? So radicals, roots, and rational exponential form. So rational exponents property. So this one, base raised to power over root. Root, square root of base. So if you can write this one as this is from rational exponent, and then this is the radical form. So root, square root of base, quantity, root, like, and a root, root, base, and power, right? Then, or you can write that as, you can place the power inside here in the radicand. Okay, so here the number, root, and base, whatever the base is, and the power, right? So x to the power, or in symbol, or in example, particularly this one, x to the power of m over n. You can write this as nth root of x to the power of n, or this one, nth root of x to the power outside the whole radical m. So it's just the same thing, right? Okay, so I actually interchange the two. So it's supposed to be this, this one means this thing, and then this second one means the first one. Alright, so you might notice, what does this flower stand for? So if you take into consideration a flower, right? So it's a flower. So if you, and then there's the soil or the land. Okay, so you can place it as a fraction bar, and then here are the roots, right? So if you take as flowers equal to power, right? And then this one, fraction bar over the roots. So it's power over roots. This is what it means. Okay, so flower, power, and then over the roots. So your roots here are the denominators of your exponential rational exponent, right? So your nth root here is the denominator here. Your power here is the numerator in the exponential rational exponent. So that we can put this into examples. Let's have examples and discussion. We'll start with transforming rational exponents to radicals. So first example, we have x to the power of 1/3. So here earlier, first is we're going to transform first 5 items to radicals. So from rational exponent to radical. So this is our root, right? Remember, this is our root and this is our power. So easily we can put it like this, right? So your root, the base x, then the power 1. So is there a need for us to write 1? Okay, there's no need. So therefore our radical form is cube root of x. So you read it as cube root of x. Next example, quantity 7x raised to the power of 2/5. So you can write it easily as 5th root of, so this is our root, so the denominator, the roots, okay, the root here, and then the base, which is inside the parenthesis, becomes the radicand 7x, and then here is the power 2, numerator here, right? So 7x squared. But still you can simplify that one as like this. You can distribute the 2 to 7 and then to x. It becomes 7 squared x squared. But still you can simplify the 7 squared. So it becomes 49, right? So therefore your radical form is 5th root of 49x squared. Next example, x to the power of negative 5/2. So when you encounter a negative exponent again, we need to use the negative law of exponent, make it positive first before we put it into radical form. So put in the denominator, make it positive, and then we apply the process we applied here. So 1 over x to the power of 5/2. Then here is our root, and then our base is x, and then our power is 5. So we can write it like this. Since our root is 2, therefore we don't need to write it anymore, right? but we have to write 5. Therefore, our radical form is 1 over square root of x5. Next example, x to the power of 3 over 7. So basically, you just have to identify your root, your base, and your power. So this is our root 7, so therefore 7th root of x base. So 7th root of x base x, and then to the power of 3. So 7th root of x cubed. Alright, next is, last example, quantity x plus 1 to the power of negative 1/3. So if you notice, there is a negative sign. So we make it positive first before we do the process we did here. So equal to 1 over quantity x plus 1 to the power of 1/3. And then since it's already positive, we can now make it into a radical form. So 1 over cube root of x plus 1. Next, from radicals to rational exponents. So cube root of x5. So basically you just have to apply the flower and then the land over the root, remember? So this is our root, our base, and then our power. So we can write it as, write first your base, then your power over the root, right? Next, so again, identify your power, base, and then your power, base, and then your root. So if you put it together, the power here is 1, since 7 is, we can separate, we cannot put 7 here in 8, right? So we can write it less like this: 8 to the power quantity 8x7 raised to 1/5. So you might be asking, sir, can we still put it here? What I mean is, we use the exponential. Yes, you can apply that. But this part, you can just see the thing goes to complicate more. You can express it like that, the way you wanted it to, but this one is more easier to see, right? You may write it in this formula. Next is square root of x5 y6. So basically you just have to copy everything and then raise it to the root and the power here. It's general one. So again, you can also multiply, use the exponential law, so you can have it like this: 5 halves y over 6 over 2 or x to the power of 5 halves y cubed, right? Okay, next, last example, 7th root of 4a8 b cubed. So you can have it like this. So this is our root. So you just have to put the radical into parentheses, and then basically you just have to erase them into the 1 over 7. Okay, so if you want to practice these concepts, you can have the following items as practice exercise. And then thanks for watching. Hope to see you again. Please subscribe and click the notification bell.